James King, Jr., Black physical chemist. James King, Jr. is a physical chemist who made key contributions to a number of different fields, including nuclear energy, solar power, and anesthesia. He also managed research projects at the Jet Propulsion Laboratory at the California Institute of Technology and in the Office of Manned Spaceflight of the National Aeronautics and Space Administration, NASA. James King, Jr. was born on April 23, 1933, in Columbus, Georgia. King began first grade when he was only 4 and was offered further opportunities to skip grades during elementary school. He graduated from a segregated high school in January of 1949 when he was only 15 years old. At age 16, King enrolled in Morehouse College in Atlanta, Georgia, with a full scholarship. He concentrated in chemistry, intending to study medicine, and graduated in 1953. King entered the graduate program at the California Institute of Technology, supported by a General Education Board scholarship from the Rockefeller Foundation and the Danforth Foundation Fellowship. He was the first graduate from Morehouse to attend the California Institute of Technology, and because of his achievements there, the university established a scholarship for Morehouse graduates. His early studies focused on the chemistry of iron, particularly its atomic relationship with oxygen and its various types of rust. He later studied the complex reactions between iron and organic molecules. In 1958, King received his doctorate degree in chemistry and physics. King began working as a research engineer of electrochemistry with Atomics International, a division of North American Aviation Incorporated. During this time, he developed a method to measure the temperature inside atomic reactors. In the 1960s, during a Middle Eastern oil crisis, King began to engineer solar-powered cars. He then accepted a post with the Jet Propulsion Laboratory, managed by Caltech, to conduct research on the physical chemistry of atomic hydrogen. At the Jet Propulsion Laboratory, the object of most of his research was the chemistry of natural and artificial gases. After studying atomic hydrogen and its relationship with other gases, King explored the theory surrounding anesthetic gases, describing the process by which these gases enter the human body. He also studied the electrical effects caused by the bombardment of subatomic particles on unreactive gases. He proved that unreactive gases, such as helium or xenon, can influence chemical reactions even if they do not join with the newly formed molecules. In 1969, King accepted an appointment as manager of the physics department at the Jet Propulsion Laboratory. In 1974, he joined NASA's Office of Manned Spaceflight in Washington, D.C. There, he directed the Space Shuttle Environmental Effects Program, which was designed to determine whether gases generated by the space shuttle would harm the atmosphere during either the shuttle's launch or its orbit of the Earth. After 2 years with NASA, he returned to the Jet Propulsion Laboratory in California to manage several research programs. In the fall of 1984, King took a 2-year leave of absence to return to Morehouse, where he assisted the college officials in building a new teaching and research program in atmospheric science. In 1988, he became Senior Technical Manager for the Space Science and Applications Program at the Jet Propulsion Laboratory. In 1993, he was promoted to the Director of Science and Engineering. King currently works on reducing atmospheric pollution. He is a member of the Scientific Committee of the Los Angeles Air Pollution Control District and has been a major contributor towards the reduction of Los Angeles air pollution. In 1993, King was also presented by the National Technical Association with the Technologist of the Year award. Citations are in the description.